Hi everyone. We are going to be working on Arduino build number 3. By this point, you should have the whole thing built, like you can see on my screen here. And if you look at me in the little corner there, this is what we're going to try to do. So you can see this LED is pretty much off, but as I turn the knob, the LED gets brighter and dimmer. So I can set, basically this is like a dimming switch, right? So this is what we're trying to make in the end. So just knob and turn it off. How are we going to do that? Well, first off, you have to build it, and that's what these directions are for. I'm going to go through all these steps. Okay, let's assume that you've already done that. All right, so now it is time for coding. Okay, so that's the wrong one. You're going to open up a brand new sketch. Give yourself a little bit of space. Okay, give yourself a little bit of space. Let's add in a comment, writing out what the goal of this code is. So in this program, we are going to read an analog signal from a potentiometer and send it to an LED. So what do I mean by analog signal? So currently, up to this point, we've only used digital signals. Before, we used digital signals. Those were when we wrote high or low. Okay, basically on or off. Digital only has two settings. Digital can only be on or off. What we're going to do today, we're going to use analog signals. Analog signals have many settings, right? It depends on what you're talking about. An LED has 255 settings, where the potentiometer has 1024. But there's lots, right? So you can be anywhere in a range. It has many settings. We'll just say it's a large range. So you can be anywhere in between. That's how we get the dimness, or the brightness rather, on this thing. So right now it's at 0, but we can turn it up, and we have like 200 different settings, or 255 different settings that the LED can be at, settings of brightness, okay? So that's why analog signals are good. Like if you're going to use an electric motor, that's what you would want to use. You don't want to turn the electric motor, so like in a Tesla, you don't want the Tesla to either be going full speed or stopping completely. You want to have gradients. You want to be able to go 25, 26, 27 miles per hour, right? You want to have options in between. So that's what we're doing here. We're looking at how can we turn signals into gradients. Okay, so we're going to start by creating variables. These variables specifically are going to be the ones that store pin locations. So we have to tell Arduino where stuff is plugged in. Okay, so we're still going to use integers because it's a whole number. We plugged in, if we look back at these directions, we plugged the LED into pin number 3. So we'll call this LED, make it equal to 3. We also plugged in a potentiometer, which I'm going to abbreviate with pot P, as in like potentiometer, pot P, as in potentiometer pin, pot P, potentiometer pin. And we plug that into A0. Okay, so those are the only two things that we plugged into the Arduino. The other things were ground and 5 volts. Those, like 5 volts does not need to be programmed. That just automatically sends out 5 volts of electricity automatically, and ground is just grounding, that just resets charge. So those do not get programmed. It is every other type of pin you would need to set like this, but 5 volts and grounds you never have to write variables for. So step 2, we need to create variables to store data later. What type of data do we need to store? We need to store data from the potentiometer, and we need to store data about LED brightness. Okay, so we're gonna basically what's gonna happen eventually is we're gonna ask the Arduino, hey, how far is the potentiometer turned? Take that data, like how much it's turned, store that in a box. When you have that information, we're going to say the LED should be as bright as the potentiometer is turned. So that way, as you turn it more, the LED gets brighter. And then if you turn it back, the LED gets dimmer. So we're going to make those two things equal eventually. And you'll see how we'll do that. But to make those data storage places, we're just going to create variables for them. So int, let's call it pot val. So the value of the potentiometer, and we don't actually need to set it equal to anything. We'll put data in it later. But right now we're just creating a place to store that data for later. Okay, int, let's call this one just brightness. And again, we don't have any data to put in there, so we're just going to leave it blank. But we're just creating the box to store it later. Okay, so we're good right now. So let's go inside void setup. Get in void setup, add a new comment. Step 3, set pin modes. In this case, LED is going to be an output because we're trying to send electricity out to the LED. We've done that a few times, so that should be old news for you guys. However, what's new is that we are going to be using, we're also going to be using the potentiometer. In this case, the potentiometer is kind of like a sensor, or it's an input. It's a way to get for you to tell the Arduino something. It's like an interface, right? So the potentiometer is an input because we're trying to give data to the Arduino to do something else with, right? So we're inputting data. So let's do that. So the command here is going to be pin mode. Let's set the LED first because we're more familiar with that. So we're going to say, hey, take the LED and make that an output because we are going to send electricity out to it. And that another pin mode command, then take the pot P, the potentiometer pin, make that an input. Now, technically, I don't think we actually even have to write this line of code because every pin is by default an input. So I don't think you actually have to write this, but we're going to put it in anyway just to cover all our bases, okay? Step 4. So we just set all the variables or set all the pins, so we should be good. Step 4, we we should open or start up the serial monitor so we can look at the data. We use the serial.begin command to do that. Okay, so I'm going to write serial with a capital S dot begin, and then I'm going to write the frequency over which we're going to communicate, which is in our case always going to be 9600. Okay, and for right now that's pretty much good. I don't think we need to do anything else right now. Let's just verify real quick just to make sure we didn't make any mistakes. Okay, and I'm going to call this potentiometer. Okay, cool. Didn't make any mistakes, so we're good to go. So now let's go into the void loop. So far this code literally does nothing. It tells the Arduino where stuff is. It creates box. It tells the Arduino where stuff is for step 1. It creates boxes to store data in for later in step 2. We set the pin modes, so like it knows which pins it's going to send electricity out and which ones it's going to receive signals. And we also started the communication between the computer and the Arduino. But we haven't actually done anything. We haven't even printed a message. So everything we're going to do this time is in the void loop. So go inside of the void loop, and we're going to do step 5. We need to read the data from the potentiometer and print it to the screen. Okay, so how do we read this? Well, before, to read a signal, we used digital dot, or not digital dot, we used digital read. However, the potentiometer doesn't use digital signals because it's not just on or off. It's not a switch. It's a knob. You know, you can be 1/4 of the way, 1/8 of the way, half, 3/4, right? So it's not a digital signal. It's not on or off. There's more than one setting. But this won't. So digital read won't work because we need to read an analog signal. To read an analog signal, we use the analog read command. So basically it's the same thing. Instead of telling the Arduino you're going to read a digital signal, we say, hey, you're going to read an analog signal. So this could be any number of settings, not just on or off. Okay, you need to pay attention to how much electricity is coming through, is essentially what that means. So let's do that. So let's say, hey, Arduino, let's analog read the pot pin, the potentiometer, pot P. But there's a problem with this. If we just tell the Arduino to read this, but we don't tell it to put that data anywhere, it's just going to forget it. So we need to add something else to this line of code. We also need to utilize this data, that data storage, that variable. We need to use that. We need to take the analog signal it gets from the potentiometer, which is going to read right here, and we need to put it in here. The way we do that is we just say make pot val, the value of the potentiometer, equal to the analog read. So you just write pot val equals analog read pot P. Okay, so that should be good. I'm just getting some more space there. Okay, then I'm gonna say, I wanna see what that data looks like. I wanna see what the data is. So to do that, I need to serial.print ln, as in line, serial print, and I wanna know what is the pot val. I wanna see what numbers it puts back to us, okay? So let's upload that code, go to Tools, Port, make sure you click on Arduino Uno, then upload that code. It'll upload. So your LED won't turn on at all because you haven't told the LED to turn on, so it's not going to. So when you twist the potentiometer, twist the knob, nothing's going to happen. But we can see the data it gives back if we go into Tools and Serial Monitor. Okay, so you can see as right now what I'm doing is I'm twisting the knob back and forth, and you can see that numbers are rapidly being printed on my computer screen. So here it is at 0, and if I move it up a little bit, in the 60s, 100, 200, 300, 400, I'm twisting it very slowly, okay, all the way to 1023. So that's important to know. The potentiometer can read from 0 to 1023, and it can do any number in between, but not negative numbers and not 1024, okay? So the maximum is 1023, the minimum is 0. Okay, so that's just important to know. Well, let's look at the, let's add a comment. So this tells us that the potentiometer will give us numbers between 0 to 1023. Okay. My question is, what numbers can the LED take? Can it take 1023? Well, let's find out. Let's make the brightness equal to the potential equal to that value, equal to the value of the potentiometer. So we're just going to take these numbers that we get from here, and we're going to directly shoot them straight into the LED without changing them at all, and we'll see what happens. Okay. So what I'm going to do, I'm going to say make brightness, because brightness is the variable we created to store how bright we want the LED to be. We're going to say make brightness equal to the value of the potentiometer, and then we're going to analog write. So we're sending an analog signal now. Instead of sending a digital signal to an LED on or off, we're going to send an analog signal, meaning we can allow it to be anywhere in between on or off. It can be half on, half off, stuff like that. Okay, so analog write, we're going to write that to the LED, and we're going to make the value that we're sending it equal. We're going to send it the brightness signal. So whatever signal we get back from the potentiometer is what we get here. Okay, so let's upload that code. And so now you should see the LED turn on. Okay, so if you look at my screen here, that's weird. Did something get unplugged? No, we look all good. Something seems awry. Okay, I'm getting a weird error. That doesn't look right. Let's see what's going on here. Let's try uploading it again. I think it just got unplugged. Let's try that one more time. Okay, there it goes. I just unplugged it and replugged it. So, here we go. Let's try that again. So look at my little screen. Still not turning on. Let's look at the serial monitor. We getting numbers back? Yeah, we're getting numbers. That's bizarre. I wonder why that's not working. Well, what if we try writing the LED to a different number? Let's turn it to 100. See what that does. Oh, I'm dumb. I had it plugged into the wrong place. That's funny. There it goes. So here's 100. I'm gonna go back, show you what happens if we set this to brightness. Just figured that out. Okay, so here we go. So I kind of get the dimming switch whenever I set it equal to brightness because that's the potentiometer value, but I can only really get it to dim in the first like half inch, and then beyond that it kind of like blinks and I don't know. It's not a good dimming switch. If you had this installed in your house, this wouldn't work very well, right? You only get the first tiny little bit of dimming, and then beyond that, it doesn't work. So that's not great. We can do better. How do we do better? Well, as you just saw, if I put in, instead of setting it equal exactly to the value that we get from the potentiometer, if we set it to equal to 100, that seems to work. You know, it's kind of dim, but it's not super dim. If I make it 200, that's pretty bright. It turns out if you were to mess around with this, the brightest you can get an LED is to the number 255. Where does that number come from? It actually comes from some binary stuff, like you know how machines like are ones and zeros. This is just like a 3-bit number or something like that. Don't worry about what that means. You don't need to know. What you need to know is that we're getting numbers back from the potentiometer between 0 and 1023. What we just learned is that the LED can only take from 0 to 255. So we need to convert those numbers from 0 to 1023 into 0 to 120, 0 to 255. I'm sorry, I'm saying too many numbers right now. How do we do that? To convert the 0 to 1023 range into 0 to 250 range, we use the map. function. Okay, so the map function is super helpful because we can take this big number range and turn it into a smaller one. We could do it the other way as well, but for right now we're going from big to small. So here's how you use it. Map syntax. So you're going to write the word map, and then you're going to open parentheses. You're going to put the name of the variable that you want to change, okay? And you want to put in the minimum min from, like, so the starting range, maybe I should call that the minimum of the start to the max, yeah, the max of the start. So like the starting range is 0 to 1023 because we're starting with that from the potentiometer, and we need to end with 0 to 255. So we want to go from this is the start, to the end, which is 0 to 255. And then we're going to put in the min end, and then the max end, okay? And if that looks complicated, it's a lot easier to actually implement it. So what does that mean? So instead of making brightness equal to the pot value directly, we're going to say, we're going to map the pot val from its original range of 0 to 1023 to 0 to 255. Oops, I forgot a comma. 0, 255. So this is what we'll have to write. Map, open parentheses, pot val, comma, 0, comma, 1023, comma, 0, comma, 255, end parentheses, semicolon. Okay, and then inside analog write, just change this this number into brightness. So that will set the LED to whatever the brightness is of the potentiometer value when it gets fixed into, translated into this actual useful range. And that should be about it. Oh, if you want to see what those numbers look like, so we have serial print. Let's change that. We'll just add another serial.print in here. Put in a tab or space or something. And then down here, we'll do serial.print ln, and we'll print the brightness number. So we can see side by side the conversion. Okay, so let's upload that code. Lovely. And so now we should have a fully working dimmer switch. Yep, I can use the whole range of that. Lovely. Isn't that cool? All right, and if we look at the serial monitor, you'll see on the left, you'll see the raw number that's coming out of the potentiometer. And on the right, you'll see the converted value. So 0 to 0, 1023 to 255, right? Because that's what we were trying to do. We were trying to get the top of the range to match the top, like the top of the potentiometer range to match the top range for the LED. And so halfway for both is halfway. So we mapped those numbers together. And that's how you make a dimmer switch. Good stuff, isn't it? Have a great day.